This video is going to show an example for determine if these two matrices are inverses, where the two matrices are 3 by 3 matrices. So here we have matrix J and matrix K. We're checking to see if they are inverses. Now to do that, again, we have to show two things because these are inverses if and only if J times K is equal to the identity matrix and K times J is equal to the identity matrix. And in this case, our identity matrix is 3 by 3, so that has to match our 3 by 3 identity matrix. That is, the top left to bottom right corners have to be 1s, and the other 6 entries have to be 0s. If at any point part of our multiplication problem does not match this, then the problem is over and the answer is no. So we're going to start with J times K. We're going to see if that equals I. Now I'm not going to rewrite J and K on this page. I will on the next page when we do the other half, okay? But I don't have quite the same amount of room here on the first page. So we're just going to use J and K from up above to do this. Actually, before I start, I am going to go ahead and copy those over to the other page just so that I have them and I don't need to remember what they are. So I'm just going to copy those real quick so that I have them and place them on this page. Okay, let's get those placed. There they are. I would really like to have moved that whole thing, so now we'll see if it screwed me up here. And it did. All kinds of problems. Okay, well, we'll just deal with that in a minute then. Okay, so determine if J and K are inverses. So we start off and we say, okay, in order to do this, I have to take row 1 times column 1 of K. So that's going to be my top left entry. 1 times negative 5/4 plus 2 times 3/4 plus 3 times 1/4. So that's my top left entry, and that has to equal 1. So let's look at that. That's negative 5/4 plus 6/4, which would be 1/4, plus 3/4 would be 4/4. So that would equal 1. So we are in good shape there. So we move on to the next entry, which would be row 1 times column 2. So that would be 1 times 1/4 plus 2 times 1/4 plus 3 times negative 1/4. And that has to equal 0. So we examine that. Well, that's 1/4 plus 2/4, which would be 3/4, minus 3/4, which would be 0. So we continue. Row 1 times column 3. That would be 1 times 7/4 plus 2 times negative 5/4 plus 3 times 1/4. That is 7/4 minus 10/4, which would be negative 3/4, plus 3/4, which would be 0. So our first row matches our identity matrix, and we are good to go. So far we have shown 1, 0, 0. So we continue. Now I am going to have a little bit of trouble continuing to color code this because I only have so many colors available. We're going to do row 2 times column 1. That is 2 times negative 5/4 plus 3 times 3/4 plus 1 times 1/4. And this is supposed to equal 0. So 2 times negative 5/4 would be negative 10/4 plus 9/4 would be negative 1/4 plus 1/4 would in fact be 0. So we are able to continue. So next up we have row 2 times column 2. So that is 2 times 1/4 plus 3 times 1/4 plus 1 times 1/4. Negative 1/4, sorry, almost made a mistake there. So that would be 2/4 plus 3/4, which is 5/4, minus 1/4 would be 4/4, which is 1. So we are still on the right track. So onward we move. We are going to do row 2 times column 3. See how this pattern is working. 2 times 7 fourths plus 3 times negative 5 fourths plus 1 times 1 fourth. And this has to equal 0. Well, that would be 14 fourths minus 15 fourths, which would be negative 1 fourth, plus 1 fourth is 0. So we continue. Now I will say that if we've gotten this far in and we have not found a mistake yet, chances are good that we're not going to. However, that doesn't change the fact that you still have to show me that work. So onward we push. Let's see here. Let's do... yeah, that'll work fine. Row 3 times column 1. That is 1 times negative 5 fourths plus 1 times 3 fourths plus 2 times 1 fourth. Now that has to equal 0. Well, that's negative 5 fourths plus 3 fourths plus 2 fourths. That would be 0. So onward we push. 2 to go. I haven't used purple yet. Row 3 times column 2 is 1 times 1 fourth plus 1 times 1 fourth plus 2 times negative 1 fourth. That is again absolutely equal to 0. And finally, row 3 times column 3. That would be 1 times 7 fourths plus 1 times negative 5 fourths plus 2 times 1 fourth. And that has to equal 1. Well, that's 7 fourths minus 5 fourths, which would be 2 fourths, plus 2 fourths would be 4 fourths. So that equals 1. So there you have it. We have shown that J times K is equal to the identity matrix. That part is confirmed. Now, unfortunately, that is not the end of the problem. That's halfway through the problem. So then we still have to continue on and show that K times J is equal to the identity matrix. So we'll try again to fix this issue here that we're having, which is that we need all of this to move down if we can get it. And unfortunately, it is all moving. So we'll just have to clean it up in place. So alright, we have this all cleaned up here. 1, 2, and this is J. So now we need to show that K times J is equal to the identity matrix. So again, we're going to use the rows from K times the columns from J. And again, that has to equal the 3 by 3 identity matrix. So that first entry would be negative 5 fourths times 1 plus 1 fourth times 2 plus 7 fourths times 1. And that has to equal 1. Negative 5 fourths plus 2 fourths is negative 3 fourths plus 7 fourths is 4 fourths, which is 1. So we continue. Row 1 times column 2. That would be negative 5 fourths times 2 plus 1 fourth times 3 plus 7 fourths times 1. That has to equal 0. That's negative 10 fourths plus 3 fourths plus 7 fourths. That is absolutely equal to 0. Then we do row 1 times column 3, which would be negative 5 fourths times 3 plus 1 fourth times 1 plus 7 fourths times 2. And this also has to equal 0. So we have negative 15 fourths plus 1 fourth would be negative 14 fourths plus 14 fourths would be a 0. All of this work is expected. If you want the bonus points, you're going to have to show the work. So then we're going to move on to row 2. And I will go ahead and color code that entire first row for those of you that are having trouble following along. We carried out row 1 times column 1. That goes in row 1, column 1 of our answer. Then we did row 1 times column 2. Then we did row 1 times column 3. And that's where we got those numbers. So onward we go. We're now moving into row 2. So we're going to do row 2 times column 1. And I'm not going to color code the entire problem because by now we should be able to follow along. So 3/4 times 1 plus 1/4 times 2 plus negative 5/4 times 1. That has to equal 0. That would be 3/4 plus 2/4, which is 5/4 minus 5/4, that's 0. So onward we push. Row 2 times column 2 is 3/4 times 2 plus 1/4 times 3 plus negative 5/4 times 1. That's 6/4 plus 3/4 is 9/4 minus 5/4 is 4/4. That equals 1, which it should. When we go to the final set, 3/4 times 3 plus 1/4 times 1 plus negative 5/4 times 2. 9/4 plus 1 is 10/4 minus 10/4 would be 0. So then we move to row 3 times column 1, which would be 1/4 times 1 plus negative 1/4 times 2 plus 1/4 times 1. That is 0. Onward we go. 1/4 times 2 plus negative 1/4 times 3 plus 1/4 times 1. That is 0. And finally 1/4 times 3 plus negative 1/4 times 1 plus 1/4 times 2. That's 3/4 minus 1/4 would be 2/4 plus 2/4 would be 4/4 or 1. So right there we've shown that k times j is equal to I, so we would say that yes, j and k are inverse matrices. Remember, if at any point in time any entry in the answer matrix does not match the identity matrix, it is a no. So there's the example for 3 by 3 and the end of this video.